Okay, let's get another flight on our converted 1 meter twin motor Cheetah chuck glider. Alright, launching. 50% throttle on launch. Getting a little breezy out now. I only have a standard receiver in it. I don't have a gyro to mitigate the wind, unfortunately. I love the power of those twin motors. That is so awesome. I highly recommend these BetaFPV motors, man. They're awesome. 2204, 3000 kV, spinning a T-mount 5x3 prop. Awesome. That is just effortless, guys. Just effortless. This is my 4th flight since my repair. Changed my protocol from DSM-X to DSM-2. So far, I have not had any issues. Other than pilot error. I did nose it in. I did nose it in because I put in too much rudder at very slow speed, stay out of the sun, and tip stalled it and didn't have enough altitude to catch it. So I nosed it in, but there was no damage. I think that was my 2nd flight, and this is my 4th one. So after this flight, that is very maneuverable. After this flight, I will meet you back at the hangar. And I will tell you, if I had to do this project over again, what I would do differently. Because there's, no matter what you do on these conversions, once you complete them, you get it out, you fly, you test it out, there's always room for improvement, right? Always room for improvement. So I will let you know what I would do differently. So if you guys decide to perform one of these conversions, whether it's twin motor or single motor, I really love this twin motor conversion though, man. It just performs effortlessly. Tons of power. I love it. Look at that. Like I said, effortless. I'll give you guys information on the all-up weight and some of the changes I'll discuss would make it a bit lighter. If I had all the components that I wanted to use when I converted this. Isn't that just maneuverable as can be? Pretty stable, even in some breezy conditions, with just a standard receiver in it. Okay, let me figure out where my wind is now. I think we need to bring it in from the opposite direction. I've got a crosswind, but I think it's mostly at my back right now. Make sure we don't have anybody coming. All right, see if we get lined up here. Gliding. There we go. Anyway, there'll be links to everything in the show notes. The gliders, I think when I purchased mine, it was $12 delivered to my door. I ordered 2 of them. I kind of wish I'd ordered 3 of them now. Last time I checked, I think it was only $11 delivered to your door. So it is super, super inexpensive. And those airframes make for great conversions. I'll try and make sure I'm running the BetaFPV 2204 3000 kV motors, the twin motors, and they are spinning T-mount 5x3 props. I think I also, and you can see how much power it has, and I get about 7 minutes worth of flights out of it with that GMB2S 550 milliamp hour ADC LiPo. So I will have links to all the stuff that I used in the show notes, along with links to the digital 4-gram servos that I really wish I had had on hand when I did this conversion. I also have links in there to some 4024 props if you would rather have it a little less power and longer flight time. With the 4024 props instead of the 5030, you'd probably be talking about, I don't know, 8 to 9 minutes of flight time, not quite as much power. So that's always an option. But anyway, I'll meet you back at the hangar and I will discuss what I would do different on this project. So if you guys want to convert one of these, yours, if you make the changes that I would make if I had to do it again, I think you're going to have a perfect flying twin motor glider that is a little lighter weight than mine. So I'll see you back there.
Okay, so what'd you think of that converted 1 meter Cheetah chuck glider? Does that have a lot of power and a lot of performance, and it's very, very stable and well behaved as long as you don't get too slow and put in too much rudder and induce a tip stall on it? And man, what a blast. So I have put all 9 battery packs through it during that flight session, and I slowly rolled out the flight videos. But converting that or changing the protocol from DSMX to DSM2 seemed to take care of the problems, guys. Exact same electronics, same receiver that I had in it, that I had 2 crashes with because I lost contact with it with the radio. And just like the F-18, after I switched it from DSMX to DSM2, that seems to have taken care of the problem. So I don't know what's going on with the DSMX protocol with multi-module. It could be the hardware multi-module itself. I don't know. I mean, on the RF module inside the radio, the 4-in-1 module. I could have a flaky chip on it. I don't know, because some people are having problems with the same type of problems with DSMX that I'm having, and some are not. I am on at least my 3rd update on multi-module since I first had that problem. So I don't think it's the multi-module software. But anyway, I'm going to stay away from DSMX going forward because right now that seems to be my problem child. Anyway, the changes that I would make to this, and I'm really, really happy with the way this turned out. But I am getting some wing flexing. I put a 2 millimeter solid carbon rod, almost the full length, all the way to the wingtip, right at the end of where the ailerons are cut out. a solid 2 millimeter carbon rod on both wings, a cross section across both halves of the wing to tie everything together. If I had to do it again, instead of using 2 millimeter solid round carbon rod, I would use one of those 3 millimeter square carbon tubes. Since it's hollow, I don't think that it would weigh any more than the 2 millimeter carbon rod, but unlike the 2 millimeter carbon rod, it does not flex. So I think that would put the stiffness in the wing that I would like to have. As it is right now, I will probably put in another 2 millimeter carbon rod in each wing to stiffen it up. But so I'm not happy with the flexing I'm getting in the wing, especially when you're doing high G maneuvers. I would rather have that wing much more rigid than it is. Okay, the other change that I would make, and I didn't have these on hand at the time that I made this conversion. I thought that I had 4 gram digital servos, but I had used those in a different project, so I didn't have those on hand. So I had to use 3 5-gram analog servos and 1 3.7-gram digital servo. So I think the four 4-gram digital servos, rather than the 3.5 that I've gotten to 1 3.7, I think that would, not only would that allow the control surfaces to maintain their centers much better, but it would have saved me about 5 grams of weight on the 4 servos. So I would definitely do that. There'll be links to all these components in the show notes: the motors, the props, the servos, the ESCs. I've got a link to the Radio Link BMA gyro in there, the WFly RF201S diversity antenna receiver. I like using those because they don't require any RF frequency tuning, and I've never had a problem with them. As a matter of fact, that's what I have in the Flying Fish, and this so much reminds me of the Flying Fish. And it appears to have unlimited vertical climb as well, just like the Flying Fish. So I am really happy with the performance on this thing. The other thing that I would change those 2 things. The other thing that I would change, and someone posted, I think, a picture of one of their conversions on our Facebook page. So if you go to our Facebook page and do a search for a converted chuck glider, I'm sure you'll find the picture. But what he did was he hollowed an area out underneath the fuselage below the wing, and he used that as a battery compartment. That was a really smart idea. I wish I had done that, because by doing that, you're putting your heaviest component, which is the battery, underneath the wing, so that it's not going to affect the CG. If I had thought of doing that, and I will do that on the next conversion, putting the battery compartment underneath the wing frees up all the space underneath the canopy, because I've got a plastic shelf in here. The battery goes on top, the receiver is on the bottom. So if not having to have the battery in here, what I could have done, putting the battery underneath the wing, I could have brought the ESCs up underneath this and put them underneath the shelf, and then put the receiver and the gyro on the top shelf. And then that way it would have given me some room to move the battery back and forth to adjust the CG if I needed to. But I have no doubt if I had done it that way, I would have been able to get the CG just moving the battery a little bit forward or a little bit aft, and I wouldn't have had to put that nickel on the very tail of the airframe to get the CG at a neutral balance, which it did. It really needs it with the battery up front. So using the 4-gram digital servos would have cut down by 5 grams. Putting the battery on the bottom instead of on the top in the canopy over here would have reduced the weight by 5 grams, because I wouldn't have had to put that nickel on there. So that's a reduction of 10 grams right there. If you're flying over nice soft grass, and you can land on nice soft grass, you wouldn't need a landing skid system and wing protectors. That's another 10 grams. Okay, so the lightest battery that I fly this with is a 2S 500 milliamp hour LiPo that weighs 30 grams. The weight of the airframe, as you see it now without the battery in it, is 240 grams. The 2S 500 milliamp hour battery weighs 30 grams. That puts me at 270 grams, right? So using the 4 gram digital servo should free up 5 grams. Putting the battery underneath the wing rather than in the canopy here will reduce it by another 5 grams. The 5 grams of tail ballast weight that I've got it. That's 10 grams, right? Okay, and if you've got nice soft grass to land on and you don't need a landing system attached to it, there's another at least 10 grams. Now you're down to 250 grams. So making those changes that I would do if I had to do it over again, you would have a high performance sport glider like this that would be at least 20 grams lighter and put you at the 250 gram and lower all up weight so that the FAA is happy. Okay, so that's another thing to consider. So you could definitely, if I had done it that way, I would have had the all up weight on the sport glider at 250 grams or less. Of course, I couldn't do that because I have to have a landing system where I land. But if you're flying over grass, that's exactly how I would have done it. So a very high performance sport glider, 250 grams or less, unlimited vertical climb, and somewhere between 6 to 7 minutes of flight time, depending on how hard you push it. If you just climb up and glide around for a long time, well, you're going to get a lot longer flight time than that. But I like doing close proximity, high-speed aerobatic flight. So I push it pretty hard and still get 6 to 7 minutes of flight time out of it. All right, so those are the changes I would make. Everything that you need for this project, other than the glue and the carbon, I think I've got links to everything in the show notes, even plastic hinges, the props, the motors, the ESCs, the receiver, the gyro, the servos. Yeah, I think I've got all bases covered for you guys. I just checked the price again. It is still just $11. $11 delivered to my door. I'm definitely going to pull the trigger on 2 more of those today. So, thanks for watching, and I will see you in the air.